Right then. Part 3, I think. Alright, what we're going to do, we're going to now, by here, we're going to send the thing back with essentially. I've basically forgot what I was doing. Oh wait a minute. Right, no, it's coming back to me now. It's coming back. Right, okay. That makes sense. Alright, I get it now. Right, very sorry about that. Right, it all come back to me now. Now I understand what I need to do. Alright, let's go back to the Linux kernel client. Let me just change this a little. Alright then, so what we need to do, we need to move this stuff out into separate functions, just keep it clean, basically. Yeah, so these kernel packets need to be moved to the empty shared. Cool. I remember last time we was failing to work with the path, so we need to fix that. Matter of fact, we'll do that now. See, by here this is no good, so let's change that. One sec, guys. Next stream, I'm gonna make sure I use something that's less intrusive, because flicking through this obviously takes up some time. Maybe go playlist. Okay, I'm gonna share this link with LinkedIn. One second. Okay, so we're going to pass that by reference and send that package straight to the kernel module, essentially. That message, send that message, not a package. Sorry, guys. I suppose we should really call this send packet rather than message, right? And we're going to break this down further, by the way. This is just the start.
A bad day, a lonely place, a life that isn't real, words that come and go, don't say what I feel, worlds come crashing down, love can fade away, but I know what lies within, where my heart is.
I'm thinking we need to make this cleaner, right? It's not clean enough. I'll break this down a little more. No, we'll just put it in blind socket for now, I think.
Sleepless nights, endless tears, fragile heart, darkest fears. Let the beautiful nothing surround you. Hear the truth of your heart inside of you. No fear can touch you now. Darkness won't harm you.
Have I done that right? I don't think so. I don't remember what it was. How can I forget something like that? Let's try that. Right, yeah. So this needs to be, instead of 1,000, you need to set that, I think, to the size of the kernel packet, which is fixed size for now. But currently you just send fixed sized messages, and you're not actually sending any additional data. That'll need to change at one point or another, because if you're sending large amounts of data, then we're going to need to support that. Currently, DNP protocol only supports things that are the size of a UDP packet, right? That's 65K, and you won't even get more than 2K of that for the email anyway. You'll probably drop it. Alright, we can get rid of all of this, don't need that. Bind socket. Bind socket takes care of that first. We need this line here, we need everything below it. Yeah, and we have a desk address there, it's fine. We should probably store that somewhere higher up in the headers as well. What am I doing? I'm being stupid.
Life without a spark. Forever in the dark.
Alright, that's done. Cool. We're almost ready. NL message data. Request sock NLH. What do I need to change that to again? Message header. And we have IOV base. Yeah. So we'll need to change how this works when we start sending packets that aren't fixed size. Right, okay,
Is it a dream?
stick the tubes in. No, stick the tubes in. Oh, right, I see it now, right. Sorry, right. Alright, we're done. That should filter the kernel successfully, I believe. Alright. Let's just see if it works then, right? So we're going to send the packet. Void send pin packet, right? Let's get the manual for send message as well, one second. Failed to send packet. Alright, nice. One second, guys. I'll be right back.
And nothing's what it seems. A distant memory in paradise. In paradise. In paradise. atmosphere, no gravity to pull you here. Million miles apart, even when you are so near. Illuminate your darkest hour. Light is all around us. Can you see me from afar? Like a flash through the night, burning bright. Can you feel the flames of my heart rushing in, falling in? Too late to catch me from the sky. I am falling from height, like a meteor.
I'm back.
I was in the dark for such a long time, walking the dry land, hoping to be found. No aligning stars where I
So we're implementing a netlink communication between the kernel and host application right now.
Total eclipse of my senses. Let me down deep within. Out of the ashes and out
So we're going to send a hello packet to the kernel module, and then I'm not sure what we're going to do from there. I guess I'll find it. I guess I'll make it so the kernel module locks the process in, and no one else can say hello. But that could be error prone, so we need to be careful with that. What if the process crashes, for example?
I will rise like the morning sunlight does.
And then obviously the kernel will send the thing back to confirm that it's working appropriately. But for now we'll just send one ping packet and we won't receive. I haven't compiled this in about 30 minutes, so no doubt there's a few things which are clean up. Then we'll, yeah, exactly. Let's fix these thanks errors and then we'll modify the kernel module.
Eclipse of my senses. Let me down deep within. Out of the ashes and out of the dust, I will rise
call. Alright, that compiled successfully, which is great for us. Let's get to the kernel module. I got to be careful in the kernel module because if I crash my machine, the stream ends. And my PC is really old, I won't be able to run the virtual machine and run the stream at the same time, which is won't cope with it. Okay, nice. So this is our kernel server. Currently, it just returns call. It just sends call back, just to test, basically. What it will do is it'll try and receive the ping packet. If it gets sent, then it will basically say that there's a connection. And then where I've registered my datagram protocol, you can send DMP packets using the socket interface as you would send UDP packets, but you don't specify an IP address, you specify an ID. And then what happens is the kernel module will talk with a host application, which will then send that packet to the network, and it will bounce around until it's received by the party, right? Which is really good because you can communicate without IP addresses. Obviously there's IP addresses at the lower levels, but it's abstracted, you don't see that. And the good thing about it is, what I could do in the future, I could make it so you can mark it that it has to be delivered. And then if it can't reach its destination, because I don't know, their computer's offline or something, then it will be stored around the network, and when they next come on, it will be sent to them. It's pretty cool. It's just datagram type of protocol at the moment. I'll make some sort of TCP equivalent, maybe see how this goes. Alright, let's now compile the module and run it. And I just hope it doesn't crash, right?
It's me and you. It's me and you.
Yeah, man, I crashed my machine last stream, so if it cuts out, you know why. It probably, there's a chance it could happen, so. I should be using a virtual machine really, but PC won't be able to cope with the stream and the VM at the same time. I've tried it before. Alright, register protocol family 43. I need to change these to unique pointers, I think. Right, so host, kernel client star. Alright, so that should work then. Let's try this. In this particular stage, I shouldn't have to include the kernel include. So I'll probably take some of the headers, take some of the includes out of the headers at some point, because No, I don't like to have to do that. Alright, let's try this. Okay, that didn't work. Alright, let's find out why that didn't. Oh, it might have worked. Let's just see if it sends the packet here. Right? I don't know. If it did work, then it wasn't displayed on the kernel side. It wasn't outputted, which is worrying. I think I forgot to install it. I think I did make all rather than make install, so that might be why, because it uses the library from the lib folder, lib directory. And there we go. Right, it says failed, so that's not good, but we can see it was received because the kernel outputted call. So that's good. Failed to send packet, only 20 bytes send. I need to find out why that why that was. We've unregistered it without a system crash, so that's good. Oh, wait a minute, right, I think what I should have done was check the message header, I think. I'll tell you, we're not going to rely on this for now because I need to think about how I'll do that, because we send a message which has a pointer to the base. So I don't know if there's any point set here until I can, because I imagine send message it only returns the size of the. I don't know. We'll just keep it like that for now until I think a way to do that properly. I'm making a decentralized network protocol. So you send the packet to an ID rather than an IP address. It's the 32-byte hash of a public key, and that's your ID. You send a packet, think of a UDP packet. Rather than send to an IP address, you send to an ID. This then gets sent to the decentralized network, where it's routed around everyone on the network until it's received by that person. And once it's received by that person, then it's obviously resolved. The benefits to this is you don't need to be port forwarded, so you can use this anywhere in a cafe or whatever and talk with each other. Second benefit is I get around that with hole punching. Second benefit is we could potentially in the future you could store the packet. If the user's offline, the packet can be stored right on the network and then sent to him again when he's back online. So he can basically receive packets even if he's offline, because as soon as he comes back online, it'll be sent to him. That's the basic idea. The original idea was much more complicated, but I think I've complicated, so I've stripped away like 1,000 lines of code the other day, and just doing bare minimum kernel module now. So you'll create a socket interface like this in user land. So you can see you set up a socket using the DNP family. It's a raw socket, and you use the DNP datagram protocol, and then you'll send some data to it. And this is a dummy option I've made. DNP socket option must deliver. And what that would do in the future is, if the packet isn't received, it will be stored on the network, and when they're back online, they'll then receive it in the future, basically. Okay, so instead of returning false here, instead of pinning call here, we need to actually deal with this information now. So yeah, we should definitely deal with that information. I need to figure out how to do that actually. I'm not sure. Oh, let me turn the music down. Sorry. It's a it is sent at the lowest level. Is sent with an IP, right? Obviously, what happens is, well, this is what will happen. It doesn't happen yet. Let me show you. So what happens is you send to an ID here, which I haven't specified yet, because I'm still thinking of the way to do that properly. When you specify the ID and you send the packet, what happens is it goes to the kernel module. Now at this point, the kernel module says, do we have a user application binded to us through a net link? And if it does, then it'll process that. Otherwise, it'll return an error, right? Because I don't want to be dealing with this complicated logic in the kernel. It's dangerous and it'll be more difficult to get right. So what happens is, instead, there's a user application that runs. It talks with our kernel module and it basically listens, right? So when we send a packet here, it will get sent through a netlink socket to the user program. The user program will then send it to the network using an IP address, and everyone on the network will be aware of the packet we just sent to them. Although, I want to optimize that in the future, because you don't want to be sending packet to 1 million people if you don't have to, right? So what happens then is, it basically gets sent around to all the IPs until the person whose ID matches the ID in the packet, right? And it's encrypted. I say encrypted. No, that was the wrong word. Kind of, yeah. Right. The ID is a 32-byte hash, a hexadecimal MD5 hash of the public key, and then we can use the public key to guarantee that the data was for him, if that makes sense. That's the rough idea. I'm taking the idea from the previous system, which was where you would send these things called cells to the network, and you can guarantee the updates came from you using your the public and private key. So you would encrypt a hash of the data of the payload, the data you're sending, with the private key, and then it would be decrypted by all the parties with the public key, and then that's how you can guarantee that this data was sent by this person. So that's the idea. I don't know too much about how I'm going to go about the encryption with this new model that I'm doing, because I haven't really thought too much about it. But yeah, that's how it gets around. So there is IPv4 involved. I thought about having these IP groups where each group holds like 1,000 people, and then we send only to the a person in the IP group, and they send to everybody else to take the load off the off the original client. But it won't work like that. This client won't send it to everybody. It'll send it into the network, and then they'll send it to this person. They'll send it to that person. But I don't want it to be a chain, because if it's a chain, then one person being offline would destroy the whole route. But yeah, IP groups is my way around it. But to be honest with you, I've struggled to come up with a solution to this problem. The encryption problem, the original project was to send cells to the network, and cells basically store data, and then you can go and get a cell from the network to get that data back by ID. And I was worried that people would update each other's cells, and I came up with a solution. The solution was that the ID of the cell would be a public key. There would be data stored in the data we're sending. There would be an encrypted MD5 hash of the payload and a timestamp. And then anyone receiving it would decrypt that hash and timestamp. And then if the hash matches the data they provided, then obviously they were the sender. So that was the solution to the security problem, but I still haven't been able to come up with a solution to getting around the potential latency issues. Like, you know, you're not going to want to send to 1 million people, you know. But the IP groups is the best thing I've come up with so far. But there's still issues with it that I'm trying to think about. Like, how do you decide when someone should go into a group, and how do you decide when a new group should be created? And more importantly, how do I keep that in sync with everyone else, so people don't create groups if they don't have to? You know, so there's still a lot of things to think about with that. So the original implementation would be very simple and would probably not work efficiently after, you know, 10,000 people. So yeah, that's the idea, but it's going to take a while because I need to think about that properly before I implement that, because there's a lot to think about. Right, let's look at this then. So what I need to do, I need to find out the process that's sending that packet. That's the first thing I need to do, because I don't want multiple processes to bind to this module. The second thing, will they be able to? I should test for that actually, so I don't waste my time. Yeah, the second thing we need to do is I need to figure out how to get the data out of this thing, because I honestly don't know. I think, is it a little like how I implemented the socket, where we get the send message? So where is it? Send message. So did I implement it? I can't remember. We get the user message, kmalloc, iov len. Yeah, and then we copy from the iov base. So I wonder if it's a little similar like that or not. I'm going to have to look at the docs for that and figure that out, because I really can't remember. But anyway, I'll be right back, guys, because I'm going to make coffee. So help me think a bit clearly. I'll be right back. Okay, thanks for waiting. In the meantime, I found the solution to that problem. Is NL message data. That should do it. So you have a kernel module. Yeah, absolutely. Yeah, I mean, I want to do it in kernel space, but it's a bad idea. I think. I mean, everything inside me is telling me don't do that because I'm going to be writing to files and everything. You know, because I need to keep a history of the IP addresses, so that when you next boot, it doesn't have to ask the network for an IP list again. And plus, you start with one IP, and if that IP is offline, then you can't connect to the network, right? If that's the only IP you have. So, yeah, the user space is doing the heavy lifting. I did wanna make that in the kernel, but it's not a good idea. I don't think. A lot of bad vibes thinking about it. Plus, if anything goes wrong or there's a security hole, you know, you don't want buffer overflow in the kernel. Do you know what I mean? Could be a dangerous game to play. Yeah, exactly. I know. And not only that, there's security concerns about this. There's a lot of security concerns if we do that. I mean, I don't expect this to go anywhere. This is just you know, a bit of fun. I know there'll be a standard eventually. It's the way things are going. I don't think it will be my protocol, but you know, somebody out there is going to make a protocol. You know, it's going to be probably part of. You know, you have TCP, UDP in the future. There'll probably be another layer for this stuff as a default. Because I believe everything's going to go decentralized eventually. Yeah, so we'll change this from message to packet, I think.
Excuse me if I write on my wrongs. Excuse me.
So what we're essentially going to do, we're going to send back a hello. Going to send a hello back to these guys, and then they know that it was successful. I'm not sure if Netlink guarantees packet delivery. I really hope it does. I mean, it's not even the local machine, right? But if they have a buffer or something, and if it gets too big, I wonder if they'll drop packets. I really hope not, because I haven't read into that. And if they do drop packets, then it could become a problem. I'm quite a novice with this Linux kernel protocol stuff, by the way. So you know, I'll probably be making a few mistakes along the way. I've already crashed my computer twice on the last stream because I can't test on a virtual machine because my PC is too slow to stream and do that at the same time. It's stupid, to be honest. I'm playing dangerous game running this untested kernel stuff on host machine, but you know. Alright, so they give us a kernel packet, and then we say hello. And we're just going to test that a minute, just to see if that was actually received, right? Just test it as we go along. maybe you should get an RPI to test with. Yeah. I mean, I got a Pi. Maybe I'll use that. You know, maybe I'll use that. I mean, I was thinking of using DigitalOcean, which is a VPS provider, and doing it on there, but you know, they charge me per hour, and it's not a lot, but if I'm doing this project constantly, you know, it's going to add up to, you know, $10-20 a month. No, less than that, but it's $5-6 a month, but you know, it's still lost money for no reason. All right, cool. Let's now rebuild the kernel module, load that thing, and hopefully we see hello with an exclamation mark, right? Register protocol family 43, brilliant. Let's run the program. Yes, we see hello, brilliant. So our module's starting to realize what's going on. So that's good news. And now we just want to send a hello back, you know, just to confirm that yes, we acknowledge you. I honestly have no idea how to do that, to be honest with you. I'll have to find that out. Give me 1 second, because I do have an example project somewhere. 1 sec.
How many times did we make it? Did we fake it? Did we feel? How many times did we make it? Did we fake it? Did we feel?
Okay, yeah, I got some stuff I can do here to get this to work, I think. I'm gonna paste that in there in a minute, right? Alright, I need to read up on those things to understand them. One of the things I really dislike about the Linux kernel is they make massive they make quite a few changes to the prototypes per minor version, which makes it really difficult to get this thing compiling. Like if for example, if I was on 4.16, I'm on 4.50 version kernel 4.50. If I was 4.16, I would probably need an entire different prototypes to get that to compile properly. But then it definitely doesn't compile on version 5. So that does make it a little difficult trying to deal with that stuff, to be honest. Okay, so NL message new returns buffer by the looks of it. SKB out. Obviously I'm going to abstract this more. I'm just going to put this here for now just to see. And then we have another NLH. NL message put. Let's look at that. Yeah, I know, it is a pain though. But, you know, they're constantly improving, so, you know, I respect it. This is a good tune, actually. Let's keep this on. Sounds like an advert. Add a new netlink message to an SKB. And then we have a message type. NL message done. Let's take a look at that. We're going to put this in a separate function as well, guys. I just want to understand this a little more. Okay, end of a dump, overrun, error, nothing. I really don't understand that. We'll just go with done. Yeah, this is a classic. Okay, so we mem copy. I take it NL message data. I take it that returns a pointer, right, to the actual data. That's what I reckon is happening. Let's just make sure this goes. I can't think of what else it would be doing. Yeah, so I was right. That's fine. Alright, NL message data returns where we need to copy the data, that's fine. NL message new, and then we pass in the message size. Let me double check NL message new just to double check if they're pending the size of the SK buff structure. Yeah, it looks like they are. Yeah, that's fine. See, NL message plus the payload. That's fine. I just needed to make sure that we don't want any memory issues here. If I'm honest, I should probably turn that into a definition. Can you use size of in the definition? I remember having problems with it before. I can't remember. Right. Let's just and then unicast. Then I guess that sends it to the guys or to the programs. It did. I remember there was a process ID that was required. So we need to look at that. Oh, port ID. Okay, that's interesting then. 'Cause I thought that was a process ID. You know, bear with me. That's process ID, right? Alright, yeah, it's a process ID, but I'm not sure if it is that way by default, because I've taken this from an example project. Is it safe to say that it's a port ID? I mean a process ID. Tell you what, let me go back to that example. Give me one moment.
Shot, one opportunity, seize everything you ever wanted, one moment, did you capture it? Just let it slip. Yo, his palms are sweaty, knees.
Yeah, it looks like a process ID, but I can't be sure. Let's look at the NLH structure and just read that. Sending process port ID, right? Okay. See, when they said PID, I immediately thought process ID, but I guess that means port PID could mean port ID as well. That makes so much more sense. Be a bit easier now for me. All right, I got everything I need to do this correctly. I got everything I need to do this correctly now, so I guess we can I guess we can start abstracting this out. Although I gotta watch out that I don't panic the system, because there's a high chance of that happening, because I'm dealing with new territory for me. Okay, that looks alright. Do I have to destruct these though? Or does the kernel destruct those? I mean, delete the memory. We're not in C++. Do I need to delete the memory to those, or does the kernel handle that? That's a worry. I really don't know. I don't know, but I'll need to find that out, but we can worry about that later. So we're gonna need a mutex. We're going to need a mutex for this as well. I think it's the define mutex or something. Lock mutex, is that it? Oh shit, I don't remember. Define mutex, is that it? I think. Define mutex, but I don't remember what the functions were to lock them. Alright, back to the example project, one sec. Right, I remember now. I remember what it was. So we need to create a lock for accessing we need to create a lock for accessing the particular information. I can't remember what it is. Let's just call it that until I can think of what I'm thinking.
A life that isn't real. Words that come and go. Don't say what I feel. Worlds come crashing down.
Oh yeah. I remember what it was now, right? Yeah.
But I know
PID lock, PID lock.
is within where my heart is, where I am understood. I can be with you. That's my only truth.
Yeah, I'm not sure if we need to or not. I mean, part of me would think the kernel would free that because it's used for this one operation, but then again, you know, maybe they don't because maybe you want to reuse it. I'll need to find that out because that's really important. You can't have a leak in the kernel. We'll all know about it when I start sending 10,000 packets to my protocol and all of a sudden my machine starts slowing down. Alright, it's an unsigned integer. Alright, good. I will take a look in the code myself to make sure of that. Yeah. I mean, I thought to myself maybe they would free it because it seems like it makes sense. But then on the other hand, I'm thinking, well, you know, maybe they want to keep you having that control. I'll make sure to read through the kernel to make sure anyway.
It's all that matters. It's all that matters.
Okay, yeah, cool. So I'm only going to have one PID because I only want one server listening. And what I'm going to do, if anyone else tries to bind to us and send us hello, I'm going to reject it. We're not going to allow them to work with us if we're already bounded.
How many
Although, can you bind? I don't. The kernel might reject it anyway if someone's already bound it. I don't know. I'll need to check. I'll need to make sure.
Before you see your mistakes, addicted to the highs, crushed by the lows, existing in between where you were and where you go.
All right, let's think about where to lock this mutex then. I don't think we want to lock it for. I suppose we'll just lock it here, right? Chances are I'm gonna make a mistake eventually, but you know.
Tears, fragile heart, darkest fears. Let the beautiful nothing surround you. Hear the truth of your heart inside of you.
All right, let's name this a little better as well.
Darkness won't harm you. Just hold on to one thing, a beautiful nothing.
Yeah, exactly. Alright, DMP kernel server set PID. Alright, that should work, and we'll use a mutex. I mean, because it can fit in a register, I'm unsure if we would even need to use a mutex. But I wouldn't want to chance it. I mean, I don't know. Would you? Do you need a mutex if it can fit in the register? I don't know. I don't want to find out. Alright, cool. So what we need to do here then is actually the lock can't go in there because I remember that there was other things I needed to do. I need to check if they've already if we already have a PID, right? Because if we already have a PID, then we need to reject them. Or I guess we could do that here, right? And keep it cleaner.
As I melt into the ground, there is calmness on the water. Moving slow.
Yeah, okay, I guess we can do that here, right? What we'll do is we'll say by here, we'll have a boolean here. Dipping kernel server. You know, I won't even do that because I know I'll forget that it isn't locked later on, and it will cause me huge problems. So what we're going to do, if PID equals if PID does not equal -1, then we want to return. Oh wait, but then now we're stuck in the lock. I'm so used to coding in C++ where a lot of this is taken care for you, where you know, like unique pointers instead of lock guards, right? Let's do this properly. So if the PID does not equal -1, then we have a problem because someone's tried to bind to us twice, which they shouldn't have done. The only issue with this is if the process terminates or something, you know, then we won't be able to start back up. Let's just check. Let me just check if you can actually bind twice. Because if you can't bind twice, then I have nothing to worry about anyway. Let's just check. Ah, okay, bear with me. Can we not pass structure by referencing C? Alright, let's use pointer. Okay, fair enough. I thought you could. Alright, okay, yeah. So there's some other things you can do here then, right? Message size will be the size of DMP kernel packet. And then our actual message, then I guess that would be the packet. Right, yeah, give me 1 second guys, I'll be right back in a sec. Right, I'm back. Right, let's have a look at this. Alright, that should work fine. Alright, now we just need to resolve these headers. What? Oh, brother, what was it? Was it new text locked? How did I forget it again? DNP host again. You'll notice all these bytes because F2 is the key to talk, so. Alright, we combined twice. That's not good. Don't like that at all. That's a problem. Which is fine, because that means I can just do it in here, the PID. Okay, so what we're going to do then, we're going to say if the PID equals -1, does not equal -1, then it's already been selected. And I'd love to just return here, but then the lock isn't unlocked, so we can't do that.
Without you.
We're just going to create some flags. Not flags. Flags the wrong word. Some definitions, I guess, for that. I think enums are in C, right? I think so. I try it.
You were meant to see the morning light. Held in my arms, angel flight. You are meant to see the morning light. Held in my arms.
Alright, so we'll return DNP kernel server PID already said. DNP kernels. I know I could use a boolean. I dislike using booleans, to be honest with you. It's not as clear in my opinion. So I try to only use booleans like in scenarios where it's like, is this set? Has name, has this, has that. Otherwise I like to use stuff like this. It's much more clear.
My angel fly. My angel fly. My angel fly.
So we can start with OK, I guess, and then change it to an error as we go down. Yeah, C++ is great. There's still there's some really good C++ programmers out there, and I try to get to their level. Yeah, I'm fairly decent. But there's some people out there that make me look like I've just written hello world. Okay, brilliant. So PID is already set. DNP kernel server PID already set. Nearly spoke T. Right. We'll output a kernel error here if this happens as well. I need to figure out how to show the errors in the D message. I can't remember how to do it. It only shows the info to me. Right, never mind, we'll just do this. Yeah, I know, you really can, yeah. It's impressive. Some of the C++. There's a guy on YouTube, Biscuit or something. Biscuit. I can't pronounce it. It's Biscuit spelled weirdly, right? Anyway, he's the best C++ developer yeah, that's the guy. He's the best C++ developer I've ever seen, to be honest with you. Yeah, he's one of the best programmers I've ever seen in my life. I messaged him a while back for some advice on creating compilers, actually, before I wrote a compiler. Yeah, he did. Yeah, he replied. I was one of his first subscribers, like within like the first 100 or 1,000 people. I can't remember, but you know, he has over 100k subscribers now. He writes emulators and everything. I've written some emulators, but I never finished them. But no, I remember what I messaged him about now. It wasn't about a compiler question. It was about the chip 8 interpreter, and I messaged him like 4 or 5 years ago on that. I wanted to learn a bit more about that. Okay, so what we're gonna do then? Kern error, failed to set PID. And then we're gonna relay this back to the client. No, yeah, he's made quite a lot of videos since I watched his video yesterday for the first time in a while. Right, let's look at this then. Failed to set PID as PID is already set, good. And then we need to go to out. I don't like using goto, right? But I see it quite frequently when it comes to the kernel stuff, so maybe that's the right way. I don't know. Yeah, there really is. Yeah, I agree. Since then, I attempted a Z80 simulator, and I took it quite far. But then I took it quite far, but then I gave up on it in the end. Not because I couldn't do it, because I got a little bored after a while. It was quite a big instruction set. But I've written x86 assemblers and stuff for my compiler. Yeah. I rarely code C on its own. You know, I mean, I usually use C++. I do want to make some more projects just in C, to be honest with you. But I do appreciate C. It's a nice language. Okay, so if the PID does not equal -1, go to out, and then we unlock the mutex. That's fine. That's completely fine. That works. Okay, so what I'm going to do, I'm going to move these definitions to shared so we can see them in userland. It'll just make it a little simpler for me to, rather than making separate ID, rather than sending back separate information, it's a bit pointless really. God is cool, and I think it's fun, but people can Yeah, I know. I think they can definitely be abused. I think PHP has a go-to as well, which I really disagree with, like having that in PHP, to be honest, but I think it has a go-to. I think.
We lie beneath the stars and watch the universe expand. You try to explain everything.
Alright, let's see then. So we said that, that's fine. Then we want to create a new packet for this. I don't want to send back a hello. I want a hello response.
And darkness took you home. How am I supposed to carry on?
I guess I could change these into enums as well then, to be honest with you. You know what, yeah, let's do it. Let's change the enums.
Night beneath the stars. Night beneath the stars. Darkness took you home.
Now I know when I wanna change this so it sends any amount of information you want. I know I'm gonna run into problems due to the way I've set this up. Basically currently it's like I'm talking as if it's UDP, right? Fixed packet sizes and stuff. But this is just because I'm starting off with this stuff, and then later on I'll expand that so you can send, I don't know, like a gig packet or something downstream. Not a packet, you know, like send a gig of information downstream. You know, I suppose actually maybe it doesn't make sense to return that, because a hello could fail for many reasons, right? Not just this. So I guess we're going to need to have that actually, something separate. Why am I writing case? Jesus Christ. You can tell the coffee's wearing off, right? Alright, so DMP hello response. Okay. DMP hello response. PID already said. I will just send this back to userland basically. This is starting to look a little ugly, to be honest, so I'll probably clean up this file tomorrow. I think sometimes the define looks better than the enums. Sometimes I reckon. If you ask me, I think the define looks more clear than this what I've done here in this particular scenario. Right. Okay. Yeah. So we're gonna have a DMP hello response. Hello rest packet will be hello response packet. So I should break this up really into separate function, right? But I'm just gonna put it here for now because we're running out of time. It's getting late. Kernel packet. Yeah, I was talking to myself. Don't worry. You only hear me if I press F2, right?
Moving through the night with you here by my side. Changing
Alright, packet type.
writing out
Hello, kernel response. I may change some of these enums back to definitions because it's getting a bit difficult to read them because I've lost so many of them. Yeah, it does, yeah. I'm thinking maybe keep the protocol stuff as definitions and have the enums for the actual response codes and stuff because it's getting a bit confusing. DMP kernel packet type hello response call. Bugger, you know I'm missing one very important thing. I forgot to memset that knowledge. I think I forgot to do that on the client side too. I'll need to check that because that's important. Right, okay, so this is what we're going to do then, right? Okay, only if they send hello will we add this PID to the list. That's the very first thing. So we're going to set the PID here. DMP kernel server set PID. Yeah, good. And then we're going to look at the response for that. I'm going to clean this up, by the way. Just because we don't have much time, I gotta rush this just to check the works. Okay, cool, yeah. So DMP kernel server set PID, and this is all the hello will do, right? We don't even, I don't think we even have to check if it was successful on the kernel end, because all communication will be done through the PID, which doesn't even get checked unless this was set. So I think we're okay in the clear there, to be honest. I think we can just set it and just send them back the response. I think that's fair enough. Oh no, we do need to check it because I changed it. Yeah, no, we do need to check. I go in. Yeah, we do need to check it because we have a hello response, right?
connection through sound. Connection through sound.
I know this is starting to look really ugly now, I know that. I'm gonna change this properly tomorrow. Right, so I have a switch here as well, which should be in a separate function. Yeah, I definitely need to make this a bit easier to read. Yeah, it's definitely getting a bit messy now. Yeah, I'll definitely need to do something about this tomorrow before we continue anything else, because it's starting to get a bit hard to read. Anyway, yeah, we can sort that out tomorrow. It's getting late. Right, yeah, so default response is okay. If there's a problem, we set it. That's fine. So we're gonna go res. There we go. Alright, that should work, I think. So I can compile that.
When I look at you, I can see beyond your eyes, innocent and blue, and it's me I recognize. Reflections of a child, long ago I left behind. Soon you'll find it's lighter than you think.
Oh, okay, right. Let's put those in. That would have worked in C++, I think.
Life never ceases to
Yeah, okay. That's fine. It's just complaining about things that it wouldn't complain about in C++. I gotta get back to realizing I'm in C because I forget that sometimes, right? Oh wow, look, I forgot something there. I'm glad I didn't run that code. Right, line 38, that's important. I may actually configure it so it doesn't complete the build if there's warnings.
Life never ceases to surprise.
Just build it again, make sure there's no more warnings.
Dreams still somehow crystallize.
Alright, nice, that worked. Oh, wait a minute, what am I doing? I need to go back to userland. Yeah, so here we need to actually receive the packet. Which I'll be honest, I have no idea how to do that on the net link. I wonder if it's similar to the way we send it, maybe. I imagine it's the same way, right? You know, I need to double check that. Yeah, I know it's removed in C99. Maybe I'll change the standard, to be honest. I'm gonna have to call it here because I'm too tired to think. I need to receive the packet net and basically check the response in the user plan. And then if there's a problem, basically say to the user, host already running or something like that, or host already funded. Because I don't want multiple agents on the phone to the user programmers. I don't want multiple of them. There needs to be only one. I want to use the kernel to restrict that. Basically ignore anyone else that tries to. We only want one person binding at once. All the others will just send back that response saying sorry, can't do it. So yeah, when I next stream, probably be tomorrow. Follow me on Twitch. Yeah, so if you want. So tomorrow what I'll do is, or tomorrow when I next stream, I will be basically cleaning up the kernel code for the mess I made in the last 30 minutes. And we'll be getting that working. Alright, cool, take care. Talk soon. See you guys.